Yeah, I'm here to talk about system design.
I go by no fluff engineering because I don't like the stuff where people just draw boxes for the sake of it. I want people to go deeper. I prototype a lot. So, but when I'm architecting a system, I always say this: whenever you're designing a system, you have to wear three hats: the hat of an architect, the hat of a product manager on how the user experience would look like, and hat of an engineer.
Would you encourage the engineers to create these prototypes in separate code repos and projects rather than implement them in the system you want to integrate them in later on? If you have to think back, what's the latest decision you made that you later regret?
Do you recommend like having this kind of approach for startups, or you're like, okay, no, you should actually plan and then do stuff?
Text of the system. So what's important to your system design depends on whether you're a startup, an enterprise product, or if you're in a FANG company or something like that.
Hey folks, my name is Arpit. I'm the co-founder and CTO of basically Profile.FYI. What we are trying to do is we are trying to build a platform where people can share their career stories.
Everyone, welcome back to another episode of This is Tech Talks. This is episode 15, and today we have our guest Arpit. Hey Arpit, thanks for joining us.
Hey, hi Santosh. Hey, hi Lars. Thanks for having me. It's quite fun. Looking forward to a great conversation.
For joining. And we have our co-host Lars joining after a long break. Hey Lars, hope you had a great break and now you're back fully.
Hi, Santosh. Hi, Arpit. Yeah, I'm here to talk about system design. Great topic.
Yeah. So I think we haven't done any like in-depth, like last time we did testing one, which was a pretty like interesting discussion about around an in-depth topic. Generally, we talk about like good technologies and like this, but system design is like very interesting topic for everyone because this is where you see and when I see like on the LinkedIn or Twitter, people are actually talking about it because it's very important in point of view, like as an interview point of view as well, right? Because many companies do ask this question. So uh, let's see, like I mean, I'm really excited, like how much we can talk about and how much value we can actually give to the listeners. So uh, I mean, before we go ahead, would you like to introduce yourself?
Yeah. Hey folks, my name is Arpit. I'm the co-founder and CTO of basically Profile.FYI. What we are trying to do is we are trying to build a platform where people can share their career stories. We think basically resumes are the worst way to like they do summarize your career, but they don't do justice to the vast experience that you have. So we want to enable people to tell their career stories in a very interesting way. So that has been the most interesting thing about me for last 3 months. Prior to this, was a staff engineer at Google. I led the basically Dataproc India team. So we provided managed Apache Spark on GCP. So my job was to optimize Spark workloads, especially to run better, faster, and more efficient way on basically GCP hardware. So that was quite fun. Prior to that was with Unacademy for 5 years. seen like joint company when it was about $100 million worth, and then for 5 years that entire journey I got from a one small office to massive set of offices that we had. And on the side, I do a lot of YouTube videos. I love to spark engineering curiosity. I don't want people to just look at things from interview perspective. The domain of computer science is so beautiful, but with all everything being just about interviews, it just takes away all the juice, all things that makes it interesting. So I try to spark engineering curiosity through my YouTube and my newsletter and every single post that I write. I go by no fluff engineering because I don't like the stuff where people just draw boxes for the sake of it. I want people to go deeper and be more excited about the domain. So yeah, that basically motivates me to wake up and do stuff every day. And just a couple of things more. On the side, I love to build a lot of prototypes. So in 2021, I built my own Redis I did not anticipate that Redis would change their license. Now everybody's jumping on that bandwagon to create their own Redis with the same wire protocol format. But I did it back in 2021. Then built a programming language called Revine. It's a visual programming language for kids. I want my daughter, like the first language that my daughter would learn should be that. That's my aim. So I took it to the level that I could build a Chrome dinosaur game in that language. So now when my daughter grows up, I'll start adding more features to it. And yeah, these are all the interesting things about me and a brief intro.
How old is your daughter?
She is
And
right
has
now
she
three and
learned
a half.
Rewind?
She's
Oh,
three and a
okay.
half. Yeah.
So
So
not Rewind yet.
still a 3 years, still 3 more years to go.
Okay. Well, that's interesting. That's really interesting. Yeah, I wanted to ask a few questions about your, what was it called, Profile.FI, or what was it?
FYI. So
FYI.
so we went with .fyi because it has a very nice connotation, basically for your information, and profile as a strong positive brand. So we used to call the product, like we used to have a different name called Dug Up, but it does not make people click on it or want to be on that platform. So we wanted a very strong brand name. So we did a rebrand very recently, and we are now calling our product Profile.FYI. So your entire career profile would be at profile.fyi / your first name, for example. So if you get that username, say Lars, so profile.fyi / Lars, everything in your career would be there in a very nice looking timeline. So that's the aim.
Well, now I need to grab the last username, and it's available. Great.
Yeah, go for it.
But so first question, is it free?
Yeah, it's free. We won't be charging anything for anyone. It's just a platform where you would share your career stories. You would have a bunch of experience. So our product will go live in a week's time from now. So by the time the podcast goes out, we would have been live. So folks watching this, do sign up. It would be fun. We figure out a lot of interesting use case for LLMs as well. So we have a very small, teeny, tiny, basically custom LLM running that helps people write better stories. Uh, we have we have tried to simplify the flow about basically try to simplify right from ideation on how someone could think about a story that they would want to tell to writing to publishing. So we are making it as seamless as possible so that everybody should everybody has a lot of interesting stories. Like just to give an example, the last time you broke production, it's such a every engineer has a story about it, right? Or basically last time you mess things up with your colleague, or your best manager to date, right? So people love to appreciate it. So all of these things. So we would have a lot of interesting questions that would probe you to think about your career, and the answer to them would be stories that you would tell, and it would be shown in a very nice timeline. And then once you are towards the fag end of your career, you look back and you would be like, I did something great in my career. So we are going more on the storytelling side of things rather than the old resume thing, where a lot of things especially in case of resume, one thing that I don't like is, given everybody is emphasizing on a single page resume, as you grow along in your career, you have to remove those old entries, and then your past resumes, you don't have track of it. Then all of those memories, they kind of like, you have to stress yourself a bit to figure out what did you do back then. So we want this to be much more than resume, and yeah, that's the plan. So when's like what we are looking like, given that I'm already 32, soon to be 33, in next 10 years I would be in that phase where I would be looking back in my career, the things that I did, interesting stories that I had. So that's like my entire career log. So yeah, and I want
It's
all
like
of
having
them to
a
have it.
so it's like having an old photo album, although it
Kind of,
doesn't. This is
yes.
not about photos, more about the
Yeah,
stories. So
yeah,
it's about going a trip down memory lane whenever you have a need for it, but
yeah,
also to show more interesting aspects of your career than just the tech stack and the
exactly,
various roles.
exactly.
Have
And we
you,
want
Santosh, have you been looking at any resumes lately? helping to hire some engineers?
You're
You're
unmuted.
muted.
No, I mean, I'm just trying to get some referrals, but not hiring. I'm not involved in there.
I have been looking at a lot of resumes lately, and even if you're a great candidate, your resume can be super boring, and it's the first impression. Like when you have a lot of good resumes, especially, you have to cut down somehow through the stack of resumes, and then you only have the paper to look at. So you have to stand out somehow. And sure, you should have the tech stack and maybe that, I mean, that's not the only thing you need. That should be there, but there should also be other things. And I should be able to read what you did in that, what you achieved, and maybe some of these stories you're telling. That would be very interesting. Hopefully, when you ask people to tell about how they broke production, you will also remember to make them tell how they fixed production again.
Yeah.
That's usually the interesting part. Is
Yeah.
how did you fix that? And if you had that conflict with a colleague, how did you amend that or resolve that conflict? That shows a lot about your character.
Exactly. So we want to get that peek into person's personality rather than just all, like, for example, if you look at a lot of platforms, they just pick all the stats from GitHub or from Dribble or from other websites like this. Numbers are okay, lead code stats are fine, but does that really show? Like, those are okay for early stage careers, but once you are 4 years, 5 years plus, then you probably would not be as active on lead code, right? You won't be as active on GitHub because you have your family to take care of, you have other interesting things, other interesting big projects that you would want to lead. This platform would be that one place where a lot of career stories will be posted, and obviously people love, and as in the last episode of Game of Thrones, the emphasis was always on stories, right? And who better to tell, like, like the series ended with who has a better story than Bran the Broker? Obviously, everybody else had it, but still, the stories is what binds us all, and we just want to bring it out.
Okay. Well, I look forward to getting my profile. Now I got the good username, Santosh. You should get Santosh if you can, if it's not too late. So profile.fyi. Well, thank you for sharing about this new product you're creating, Arpit. Let's talk about system design. If I may ask you, what comes to mind if I ask you what's important aspects of system design? What's the most important in your experience?
So, according to me, there is no one way to look at system design. It is very contextual. People typically try to mold system design in some template, that whenever someone says, hey, let's design a system, someone somewhere created a template saying start with a functional requirement, then non-functional, then database, then data model, then XYZ PQR. But that does not capture everything. Right? So, according to me, when someone says system design, for me, it's highly contextual, which means that understand what circumstances under which you are building that system. For example, if you're working in an early stage company, your constraints are way different than when you're working in a mid-sized company and when you're working in a fan company. Right? So that is so important. So the first thing that someone, when someone is tackling system design, is to understand the context under which you are building, because at early stage company you don't care about downtime that much, right? So you can take a lot, you can chop a lot of corners in that case, right? So that you can ship things faster. Mid-sized company, you would be slightly more aware about it, and you would be writing slightly better code to make system more resilient. For a FANG type company, you would have zero tolerance for downtime. So there a lot of grilling and unit tests and integration tests and whatnot comes in. Right? So that's the first thing. Now, what is a good system? According to me, it's simple. That given the context, what is the best that I could make in the fastest, in the time which is available to me, kind of. And I would have to ensure that I minimize the number of possible low hanging outages that could happen. due to bad code push or bad database design or XYZ reasons for that. So I would try to be very pessimistic about it. So I always say this: whenever someone is designing a system, be as pessimistic as you can. Assume after every single line of code, the component is breaking down, process is crashing, your machine is crashing, there's a network partition in case you are going cross geography and whatnot, and see how your system reacts. And then you iterate and keep fixing it. But every system is infinitely buildable. You have to stop at a point which meets your constraint. Here, I am working at this stage. I want to ship it in this time. I would not over engineer things and stop here. So that's what comes to my mind when say how to design a system or what constitutes a good system.
Okay, so you're saying what's important to you is actually understanding the context of the system. What's important, so you have that, you can keep that in mind when designing the system and the aspects of it.
Yeah.
So you said earlier that you like doing prototypes or proof of concepts or something like that.
Yeah.
So how much do you think about this software architecture and the overall design of the system when you're doing these
Oh, that's a great
prototypes?
question. That's a great question. So, one thing that I definitely do is, as I said, I code a lot, I prototype a lot. My GitHub is completely filled for last 5 years. I don't take breaks and all, but it's quite fun. So I prototype a lot. So, but when I'm architecting a system, so I always say this: whenever you're designing a system, you have to wear three hats. The hat of an architect, which does high level system part, right? The hat of a product manager on how the user experience would look like, right? And how, like, user experience, who, when I say user experience, whoever is your customer, whoever is going to consume that system, right? How is that experience, latency, availability, and whatnot. And hat of an engineer. So when I say hat of an engineer, it's about the going into the nuanced implementation detail of a system. So if I'm architecting a system and I'm not thinking of implementation and I just draw random boxes just to make my system look complex, that is not a good way to do it. Right? When you know those implementation, when you go through that implementation by writing a quick prototype. For example, let's say I'm building a system which basically relays from, like, I have, let's say, three servers: server A, server B, server C, and I want to relay the message from A to B and B to C. Now, if I just draw three boxes and I don't think about implementation specific, then an SD1 might just implement it like REST API, REST API. But given I'm relaying information, I could do it with, I could do it in a streaming fashion, which reduces my connection establishment time on every API call, and I don't need to buffer it. Right now, if when I'm architecting a system and I'm not thinking about the implementation specific, I might not go into the actual code that I would want to write, but what I can do, or what I can do with this when I'm designing, what would be the best way to implement this, just making a note of it, so that whoever is going to implement, be it you or someone else, would just be aware that, hey, these are the interesting implementation specifics that we would go for, that would give us the best performance, or basically whatever you are trying to optimize for. So, and for that, for me to know that is possible and feasible, prototypes would help. So as a senior, I do expect, like when I was leading a team of a lot of senior engineers, I do expect them to have that small prototype ready or handy that would tell how implementation would look like, so that we understand the feasibility of it. Productionization and all can be taken care of later, but just that proof of concept that this works, and these are the specifics that I would want to go into. So those are the things that I highly recommend everybody to do. But again, because a lot of people, when they hear system design, they think of interview. So they say, in 45 minutes, how am I able to think about implementation detail and all? Which is where I'm more like, look beyond interviews, because at the end, when you join a company, you're supposed to build and implement a system. You're not just supposed to draw and run away. So you are accountable for any design decision that you have taken. So what is a good design decision? When you have thought it through all the layer: business, product, engineering. When you have think about your system, because business defines the constraint. If you're thinking from the business side, hey, I'm an early stage company, why would I want to have gRPC and my protocol? I don't care. REST API would work just fine. Okay? Product, user experience, availability, and whatnot, and then engineering on the implementation detail. So prototype implementation, I highly encourage everybody who works with me to build very quick prototypes to ensure that we are making good design decisions, because once we know the implementation specifics, we can make better design decisions up top. So I highly encourage that. And again, I act, so I work with them, because I also build prototypes. It's not that I just tell them ki you build it. I would just sit and relax. So I build myself. I set an example in front of them that, hey, this is how you should prototype. And fortunately, we have built some decent systems up until now with less failure scenarios. So yeah, that has helped me a lot, especially.
Would you encourage the engineers to create these prototypes in separate code repos and projects rather than implement them in the system you want to integrate them in later on?
So it is contextual. In certain cases, you can do a quick prototype separately. For example, if I give an example that I just want to know that for my use case, would HTTP 1.1, HTTP 2, gRPC, which one would work better? I could mimic the source data, destination data, operations in a standalone fashion, and I could see the performance benefit. So this is something which is easily prototypable in isolation. But there are certain things which you cannot do it. For example, when I was working on optimization of Apache Spark, and I want to change something, I cannot do it explicitly because there is a lot of things that goes behind it. I wanted that resource manager to be up so that when I'm doing that quick prototype to see, because there are so many components in Spark code base that if I think I'm just changing one, it may have a cascading effect on others. So in certain case, I could do an isolation. I can do an isolated prototype to evaluate which one is better. But in some cases, if you are working in a highly complex system, or better way to do it is highly tangled system, then it's better that you do that prototype in that context. But again, keep the effort to the bare minimum, that you don't digress and make it highly complex and almost productionized version of it. Just keep it as simple as you could, and see if it would work, and then think of productionization.
If you have to think back, what's the latest design decision you made that you later regretted?
Very interesting one. So what happened one time, I um, I was inserting a lot of data. It was building a user's notification system. So I had to store the notification preference in a database that, like, let's say user A wants email. So we had different notification type: email, push, in-app, etc., etc. So we were storing the notification preference of each user. I made some blundered decision. So first of all, separate row for each user for a notification type, one row. So which means a high fan out. One user, if I support 5 types of notification, basically notification destination, then I would have 5 rows for that user for each notification. Right? So for each notification type, let's say welcome notification, answer publish, post publish, etc. So for each one of them, I would have 5 entries. That's a stupidest decision I made. Right? I obviously re-architected it, but that was really bad. That was one. And in that same thing, the notification type, I chose string. Ugh. It just exploded our data size. Those are very limited set of values, discrete values. I could have gone with integer. Enums would have worked better, but I chose strings. So data exploded with high fan out, number one. And because the notification type was string, imagine we had 200,000 users multiplied by 15 types of notification, multiplied by 5, those many rows. For each row, the notification type was string, redundant throughout. So there were 15 unique values, but I string at every place. So that was a blunder decision that I took. Again, I was optimizing for speed of delivery, but never thought of the cost of rewriting the logic. So that was one thing that I regretted. But again, if you look at it, I went into implementation detail. Like people, when they think of system design, they would always think you made some different boxes, but the data flow should be different. But again, the system is there that you are trying to implement end to end. So even this is an important design decision that you are taking. So this is one where I regretted, but then I had to quickly migrate so created a new table, new schema, n columns, enums. So then the query latency reduced, everything became better, and one good migration job that migrated the old data to the new one. So yeah, um, it just wasted 1 week of my time to get all of this thing sorted again. But that is something that I regretted, but then was fortunate enough to fix it. So yeah, that is what basically that was one example.
Small question from my side.
Yeah.
I have worked with like I was like when I was of course very young and I was working in a startup. So we never used to actually think about system design, right? I mean, of course, we used to think of what we are supposed to do, and that's it. And then we used to start implementing. Do you recommend like having this kind of approach for startups, or you are like, okay, no, you should actually plan and then do stuff?
In most cases for startups, one monolith is good enough. Like for example, now that I'm building Profile.FYI, I do not have microservices. For
Mhm.
me, it's one monolith, one gigantic Golang monolith, one MySQL database, done. I don't want anything more than that. Right? Now that I have LLM stack, that is very good with Python. So I had to have one small Python service that does that part. And that was by design, I had to do it because Golang may, I cannot do LLM stuff that efficiently. Right? So that is why I had to have that, but no more moving parts apart from this. So I go with as minimal moving parts as possible. But again, when your system becomes more complex, when you start getting more traffic, you cannot, like, it is possible to scale this till a certain stage, but then you would have to have different components because you do not want, again, it's a great way to look at it, that microservices people think is there to solve engineering problem. It's not. Microservices are there to solve people problem. You do not want two teams to work on the same code base, because then code pushed by one is broken,
Contact.
other team is waiting on that, and then the fights and all happen. So microservices typically represent how your organization is structured rather than an engineering problem. Again, it is helping us build better systems, but adding more moving parts just makes things more complex. And again, for startup, again, one monolith works just fine, because if few people, like 10, 15 people working on a small product, eventually it can become big. That's there. But you do not want to keep looking, oh, I need to clone this repo, like repo A, B, C, to just spin
Yeah.
up a simple local product, like local version of the product. I should just be like, go run main.go, running, done. Right? So going for like optimizing for shipping velocity versus organizational complexity of having microservices and more moving part. Like I'll give one more example on that. A lot of people try to over optimize and say that I would have a Redis instance running, a Postgres or a MySQL instance running, XYZ PQ running. So they try to do everything locally, like Redis local, MySQL local, and all. In this case, I would even go a step further and say, let even that be on cloud. Because why do you want your engineers to waste time setting things up locally? Let them just have application logic or business logic locally. And let everything you provision on the cloud. The cloud is there to save you, like to just ensure that you don't have to do that setup locally. Right? So one thing that I do is, even in my case, I have one MySQL, one RDS instance running on AWS. I have 50 databases inside that, one for each environment, one for each user, or anything that I would want to create. Right? Everything has the same schema or the same set of tables, but it just ensures that my local machine only has the business logic, and I don't have to worry about anything else. So I look at it from that lens, that how efficient or how easy can I make local setup for people I'm working with. Even I did this when I was at Unacademy and at Google. I always followed this religiously, that make life easier for people who are working on it, rather than rather than on their day one, you give them a gigantic Google Doc that, hey, this is a setup instruction. And every time it goes outdated. So I try to minimize that. And these are a few things that I do to ensure that.
How much are you usually doing domain design? So the business domains, architecting that and how that changes over time.
In most cases, we do domain design itself. Like in most cases, the system, like I've been fortunate to have worked on various types of domains, but most of the design is specific to a domain, specific to a problem statement. And again, as you very rightly said, it evolves. So that's the biggest challenge. That whenever someone asks me what is the biggest challenge with system design, it's this, that you have to design for evolution. Like your subsequent iterations cannot be slower, because your CTO is expecting that, hey, it's a small change, it should take 2 days, but you should not have designed your system such that it is not flexible enough to go through that evolution. I would want to ensure, like, and that is which is where things become like a smart engineer or a smart developer would think on those terms always, that, hey, what if this changes? What if this changes? Am I prepared? Like, for example, with that notification example that I gave, although it was tedious, but I exactly knew what had to be done to do that migration from a high fan out to a small set of rows. But that clarity had to be there, that if my evolution or if my requirements change, and that happens a lot at startup, like no one plans for a quarter, everybody plans for 2 days. In next 2 days, this is what we need to do. So given that, designing for evolution is something that I very much stress. Like I put in a lot of emphasis on that. But this leads to a very interesting problem. This leads to a problem of high abstraction and over engineering. Because then people would always start to think, I'm adding a database, let me add a DAO layer. Let me abstract this database. Let me create an abstracted set of APIs because today I'm using MySQL, tomorrow MongoDB. Think realistically, is it even possible? You're not going to do that, so don't unnecessarily create abstractions. Right? First, even with respect to architecture, people do that. I have this microservice, authentication microservice, ABC microservice, PK micro on day zero, or even when they're designing. What if, like people ask this, what if this changes? Again, it is okay to think about it, but need not be you implement it today. Just have a plan that if this happens, how much effort would it require for you to adopt it? So I always I ask a lot of tough questions to people when they come up with design. Why is this complex? Why are you adding this complex? I try to probe them in that direction, that your system has to be dead simple, because simple systems scale. The more complexity you add in, more points of failures. Okay. More points of failures, less availability. To improve availability, you would add even more components. Unnecessary. So I try to probe them to think how simple their system is, how extensible their system is. And I do give them a few scenarios. What if this requirement changes? How long would it take? And in most cases, what happens is, we typically, like, uh, an experienced engineer can typically think of, like, for example, if I give this notification example again, I would know today I am supporting SMS, push, and in-app. I know WhatsApp is coming up, WhatsApp notification, like I'm talking back in 2018, that, hey, WhatsApp might be a channel for us to send notification. So I just need to be ready for that possible extension. So I had in mind that if we had to support WhatsApp or a new notification channel, what would it take? 1 DB migration, adding one column. That's it. I would not require more than that, and one API integration on that. So I had planned ready that if I had to support a new notification type, what exactly I had to do. Having that clarity is enough, according to me, rather than you, while implementing, keep your everything so abstracted out that sometimes over abstraction makes subsequent changes much more difficult to make. So I try to emphasize more on that. Just be prepared, just be aware. You don't need to implement it today, just optimize for shipping velocity rather than anything else.
I think that last part is an important point to make. That I often say this, that software is meant to be changed. That's why it's called software. So if
Oh,
you have
that's a
software
great way
that's
to
hard
put.
to change, something went wrong.
That's a great way to put it. Software is it's meant to. Yeah.
Um, you already talked about some of the points we wanted to go through today. You talked about how cloud computing has impacted system design from your perspective.
Hmm.
You are big on making it easy to set it up by
Hmm.
utilizing the cloud, so they don't have to have this complicated setup
Hmm.
locally.
Hmm.
Um, is there any other way that cloud computing has impacted your way of thinking in terms of system design?
Cloud. One thing that I realized when I was working at Google for that optimization of Spark is we never think of, like, we to date when people think of infrastructure, they think of getting that, hey, I'm getting one instance of this size. For example, on cloud, if you get if you get one CPU for 100 minutes is same as 100 CPUs for 1 minute, right? So you are renting machines on the cloud, you are renting CPUs on the cloud, right? You are renting storage on the cloud. So this flip, or this other way of looking at things has just changed my entire perspective. I'll give an example how it changed. So for example, if let's say we talk about a distributed database, in that case what people tend to think is, hey, if I make a lot of, if I let's say if I want to execute a query in a distributed fashion, and I give subsequent like if I give the same query to 10 nodes to execute, it would be much more expensive versus I keep all my data in one node and just fire query on that one node. Now, what happens is if all of your data is residing in one node, right, and it's a and it's a CPU intensive query, and on that one node, which means limited, let's say one CPU core you have to do it, right? Then you would take, let's say, 100 minutes to do it. But if you can somehow distribute it, people typically think, if I'm distributing my query, let's say in real time I get a query and I have to fire this query on a lot of nodes to get the data accumulated, aggregated, and respond back. What would happen is, my God, I would have to make network calls on each one of them, pass my query to it. They would all execute, or they would execute on the subset of data. I would have to merge. So mentally, it looks like a lot of steps. And people typically misinterpret, or they think that if the number of mental steps are more, it will take more time. It's not true in cloud. This one thing that changed in me, now I look at cloud in a very different lens, because now when I was explaining, like, on each node it would go and this and this and this, it looked very expensive. But imagine all of those machines are can do those things in parallel. So you literally have, instead of one CPU core that runs for 100 minutes, you have 100 CPU cores. Your job can finish within a minute. Right? Now that is something that people typically don't think of. So if we just change our perspective to looking at this, that we are renting things on the cloud, and you can leverage large number of CPU cores because that's what you are paying for, right? So that flips all the things. So anything around distributed computation, distributed storage, distributed database, distributed transactional systems, everywhere, this is what I see as trend also. Any new paper that I see which is getting published, they all are leveraging this fact. For example, Rockset is a great database. It's a real-time search and analytics database. They do this, and for every query that comes in, they fire it on all the nodes, rather than thinking that, hey, I would co-locate all the data on a single node. They fire their query across all the nodes, making it very like making their queries, which seems very counterintuitive, that it would be very slow. It's not as slow. It's real-time analytics database per se, right? So that changed a lot. So about a year back, I went in depth of distributed computation. So when I started going through the literature around it, especially research papers, a lot of them are trying to leverage this. So that just opened up my entire thought process around looking at cloud from a very different lens since then.
There's one issue that I normally see pop up when you're sharing a database between people or maybe between automated tests. How do you get around this issue of having shared state?
This is an NP hard problem. Everywhere, every company I worked for, same story. I could not believe every company, same story. Everybody wants to test on production data, staging not working in any company, and that's so true. Like share, and again, when you share database, be it production across microservices, problem. Be it locally, when you have to provide different environments to different teams, problem. So the way I look at it is, if I start talking about from production perspective, I do not like people typically think that it's criminal to have two microservices share a database, but I don't think that, because here's the trade-off. You either share the database across two services, or you add a network hop to let it go through the API server of other service when you want to interact. Now the key thing here is, I look at it from the perspective on how complex the changes are. If they're not as complex, it's okay to share the database, because adding that unnecessary hop, adding that API call and all may not be worth the additional latency you're taking in, additional load, additional compute load, additional API servers, not worth it. Right? So in some cases, shared state across two microservices in production, I would like directly share it between them. But again, it's superb if one is taking care of writes while other is just reading from it, then life becomes even simpler. But if both of them are updating, then depending on the complexity, that how complex of a changes the other service is making to that, right? It depends on it. Right? And if I extend the same thing in internal to organization around shared state for testing infra or this or that, that's an NP hard problem. No one's able to solve it, like, because people are involved, everybody wants it. So one thing that I saw, we tried it, but again it increased uh, the infra cost. We replicated, we took database dump and created multiple instances of it, created multiple environments, but every time people said, I want a separate environment. So but creating separate environment is a pain. A lot of those things kick in. So again, working with people is more difficult than working with computers, and sharing the shared data, especially in this internal use case, massive pain. So there are still ways to do it, but for example, branching is a new concept that has now kicked in. For example, Neon as a service which gives basically Postgres offering, you can basically fork out a new branch of your database, and any change you make goes on that branch in your database. So this way you can create as many forks from your production. But again, problem is now we are getting access to production data to users. So masking, hiding PIIs, those complications start to kick in. So again, the more of a sharing you do, the more weird issues you would start to kick in, like you would start to face. You need to strike the balance between, again, shipping velocity, business product engineering, whatever works for a business. Get like you do things as fast as possible, better it is. So again, highly contextual, but still unable to find one good way to do it. It depends on how good, like how well the people gel in the organization more than anything else.
This reminds me of something like GitOps. Have you worked with a GitOps setup?
I have not. I
Okay,
know
how
about it, but
about,
I've not worked on it
yeah,
in there.
how about something like a automatic preview environments?
That's nice. Yeah, I've worked on them. So again, we tried building something very similar, and we realized why we cannot do that, because like giving that much of the, if you have one monolith, one front end, it's relatively easier. But if you have 10 microservices, giving each one of them an independent preview environment, which means either you spin up 10 different microservices, because giving like for each environment you would have those set of microservices being spun up. Okay? That's case number one. That shoots up infra cost. Okay? If you don't do that, you say that, hey, some of the microservices would be shared while whatever you want would be separate. In that case, your database, if your databases are separate for each one of them, then they would all see different data. Because now what would happen? The shared microservices are getting some other data, while this is getting some other data. So again, preview environments are great when your infra is simpler. One monolith, one like few very like small set of microservices, uh, mostly a monolith, a front end. But as soon as you add a lot of microservices, let's say your service, your product becomes complex and you have tens of or 50, 60 microservices, then it is infeasible. So then typically that's where organization typically have production, pre-prod, uh, then may not be staging, but pre-prod 1, pre-prod 2, pre-prod 3 environments. Right? And then the staging could be just for development and quick team iterations. So they typically rely on that. And then this is what I saw at Google, where you could have an isolated environment, but they ensured that your local setup was sufficient enough for you to work on that small piece, because typically in a big organization you work on a very small component. So they had everything you needed to work on that small component. There were not a lot of dependencies, so they made those team structures such that you had to spin up very few things locally to get things done, but they were all independent, again hosted on cloud somewhere, but all independent, giving you an isolated environment to work on. So that was an interesting, but again, they have their infra. They, for them, it's nothing. They have engineering talent. They have a lot of time, energy, effort, resources to put in. Startup typically cannot. So, which is where, for example, with respect to Vercel and all, you see preview environments available, which is great way to test your changes. But again, limited to front end. If I ask complete preview environment, end to end, with all backend microservices, now that is a tough problem to crack.
Yeah, well, GitOps is one way of solving that, but then you face the issue of the time it takes to spin up that entire new Kubernetes cluster with all the microservices and databases, for example. And then you start to think about how can I share some of these resources while also keeping them isolated somehow. So then the problem becomes more complex again when once you have to balance the cost and the time to set up and tear down and so on.
And to add to that point, after some point, one person would come. Let's say you do complete isolated setup, and let's say this works for, let's say, 1 year. And in 1 year, let's say you added 10 or 15 microservices to that. Then one engineering leader would come and say, yeah, creating a new environment is taking too much time. And there are a lot of shared things. Why not just share it across them? And then things start to roll and become more and more complex, because the more people you bring in, the more ideas get in, and things start to go off track. So again, it's been there, seen that, had a lot of fights for the same. But that's the fun part of having worked in a startup-ish environment.
Okay, Arpit, is there anything more you would like to talk about today related to system design and software architecture?
So, if there was one thing that I always tell people whenever they're looking at system, it's always about like approach it in a very structured way. People typically get overwhelmed, and they think, oh my god, it's such a big thing, or in certain cases they think it's just about drawing boxes. They don't go into implementation specifics of it. I don't know why. What's stopping them from doing it? A lot of people don't. They just draw boxes, and in most cases they draw nouns or words that they could think of. For example, design Instagram, they would have like service, follow service, share service, post service. Hey, these you are just listing down different features of Instagram. All of them cannot be a new microservice. So again, if you would not be thinking of implementation, then tomorrow, if let's say Instagram adds 5 different types of reaction, haha, angry, like, and all, would you have haha service, angry service? No, right? So I want people to be slightly more aware about whenever they're designing system, think about implementation, think about writing that, and just mentally think about where would your code, how would your code be structured, so that you don't make such design decisions. Like it looks good on LinkedIn with that fancy GIF, but that's not realistic system. Right? Because you we know how real systems are built. Right? So that is one. So thinking in structured fashion, go step by step. Don't be overwhelmed, and don't look at system design from the lens of interviews. It's such a beautiful thing, because when you are designing for failures, that hey, what if after every single line of code my machine crashes or my system falters, there's a network partition, all sorts of things that could go wrong would go wrong, the famous Murphy's law. When you think of this and you know how your system is reacting, at the end of the day you'll be happy, right? Build a good system. So, but again, people want to jump into it, just want to crack interview and just get it done. If you look beyond it, your interview just becomes discussion between two peers or two potential peers of the future. Right? So I always look at it from that lens. So I just want people to follow that and be curious about things that you're learning, things that you're studying, rather than this is the question, this is the answer, done. So few was like basically whenever I write about this opinion, when I share this opinion on LinkedIn or Twitter, there's always one person, someone writes this. But who is asking this in interview? Interview only 45 minutes to do it. Like, look beyond it. Your life is much beyond than just cracking interviews one after another. Right? So I love to spark that curiosity in people. Just see, it's very beautiful domain. It's very interesting. It's going through a very interesting change. We are very fortunate to have been to witness this, the age of AI that is kicking in. It's changing so many things. Systems are evolving. Databases are becoming more and more interesting. And my interest lies in database, so I'm very much I know what's happening there. So I could see interesting things popping up. Software architecture, new architecting, new principles kicking in, new protocols kicking in. A lot of things are changing, but just that if you just think of interviews and not look beyond it, you are missing out on a lot of interesting stuff. So build that curiosity and have a bias for action towards working, and see yourself become a better engineer.
Those are some
So
amazing advice. You said in the beginning to learn about the context of the system. So what's important to your system design depends on whether you're a startup, an enterprise product, or if you're in a FANG company or something like that. And now you're also saying something I got from what you said just before is design the system for where it's most likely to change. That's where you want to invest your time designing it well for extension.
So again, this as you put it, this looks slightly in contradiction, right? Where one way we say do it as fast as possible, but then extension. It's again, for me, it's always about being prepared. That if when the time comes, you know what to do and how to do it. A lot of people think I need to do it today. You don't need to do it today. Be prepared for that, because I've always observed this, that our brain loves when it exactly knows what needs to be done, rather than you throwing it in an ambiguous situation that you figure it out. But if you have that checklist, if you know what needs to be done to do this, it's just the matter of execution. So that is what I always encourage it. Although you're thinking of edge cases, which is excellent, you should always do that. But do you need to integrate those in your design decisions today, or can you defer it? That is that is where the context in which you are building that would help. Hey, this is my priority. This is what I'm optimizing for. Everything else can take a backseat, but I would still make a note in my documentation tool that, hey, making a note, this is what is there. Whenever I require, I'll refer to that and execute.
Okay, so you are keeping track of this in some document or
Yeah, I
an
do have.
architectural decision record log or something like that?
Yes. So for me, I log everything in GitHub issues. I don't have a separate documentation tool. GitHub issues is best way to do it. I add a separate tag called future extensions. That tag, everything is attached to that. So that way, all of my plans, whatever I want to do, goes in the description of it. Because 3-line, 4-line, 5-line descriptions is good enough for you to know what needs to be done and be prepared for it. And if you happen to prioritize it, it's just about putting it into the person's plate. Right? Good enough for, because the person will already have the context. So it's just about executing it from there.
So, Arpit, we are almost at the end of the interview. So, last question from my side would be like, what are some resources which you will recommend to anyone?
Resources. Okay. So, first of all, my YouTube channel. Why not? One shameless plug. So, yeah,
Yeah.
my YouTube channel is a great way to build that engineering curiosity. A lot of people subscribe, very few people watch because everybody wants to learn, nobody wants to study. That holds true. So, I have a lot of subscribers, but very few views. But again, people who view, they get a ton of value out of it. So that is one. I don't post any random stuff. It's all no fluff. But apart from me, Hussein Nasser, obviously, he posts deep tech stuff. So going on that path is interesting. But the way I would put it is resources for people to go in system design. Let's segregate people into 3 buckets: absolute beginners, mid stage, and senior stage. So absolute beginners, don't go for high fundo videos. Go for simpler videos that explain concepts in simple fashion. You build prototypes and implement. Resources would be blogs and YouTube videos from system design videos from early engineers. Right? Those would be the one who just brush passes the concept so that you are aware of what's happening. Then comes the mid-level engineers, more than 3-4 years of work experience. That is where my channel typically adds a ton of value. Where you go into those nuances or specifics, and then you become a subject matter expert in certain thing. Right? So my channel is one. Then at this stage, you can start reading papers, because at this stage, there you would not find a lot of YouTube content that suits your requirements, because most YouTube content is focused on early stage people. Right? So this is where blogs, papers would help you. Right? So blog, papers, and books are your friend. Then comes the late stage, where they're typically leadership role, either leadership IC or leadership management. In that case, papers is the way to go. But typically, they would need to refer to, because of a huge gap that they have worked on it, or sorry, they have not worked on it. They might want to refer to early stage videos and mid size. So if they want to go into deeper of that, like if they want to understand or brush upon that concept, then again the blogs, papers, and this would help. But to give specific resources is conference videos like GoToConf, one of the best. And again, I'm mostly backend, so I would talk about backend there. So GoToConf is one which I absolutely love. I watch every single one of their video. Okay. Apart from that, a lot of good companies have their own YouTube channel where they talk about architectures, the things that they are doing, how they're solving that. InfoQ conference, amazing. Then maybe if you're into big data, then Strata or Data Council, that would help. These are all amazing YouTube channels with a lot of conference talks. Right? That is on the conference side. For papers, pick the conference that you are, or pick the domain that you are interested in. Let's say I am interested in creating database and data systems. So Sigmod is one that I refer to. Then VLDB, which is basically very large database. I go through every single of their proceeding once a while. So I read one research paper every week. So that is one. So and third one is Usenix, USENIX. Okay. So these 3 conference. Go through them. If you're into databases and data systems in general, these 3 are best. I prefer these 3 over others. So this is about papers and blogs, company engineering blogs. Again, there is this very famous GitHub repository, Kilminchoy. I'm sorry, I might be pronouncing the name wrong. But if you search for engineering blogs, GitHub repo, you'll find that as the first one. So pick one, go through all the blogs. Pick second company, go through all the blogs. Pick third company, go through all the blogs. So whenever you find time. So yeah, these were the resources. And on the books, pick the one that you find interesting. I won't say just do DDIA, because everybody starts, nobody finishes that book. That's a very common thing. You might not need to touch upon that book if you go through all of this other stuff, but that book is more of a textbook. So a lot of people typically read first 2 chapters in full motivation, full enthusiasm. Third chapter onwards, just drop it off. It's just they're becoming the next monitor stand. I see Corman and DDIA being the most common monitor stand in any desk setup. It's either Corman, basically the CLRS book for algorithms, and DDIA. So it's important to take that out and read it. But again, not everybody has that patience. So other type of resources would help there. So I would recommend that.
Thank you. Thank you for sharing. Thanks again, Arpit. Thanks for joining. I think we released the like 1 hour. I think we took more time than that, but thanks again for hanging us with us, and thanks again, Lars, for hosting the show. And we'll be back with another episode next week, and we will see you around. And thank you again, everyone, for watching. And all the links which Arpit just mentioned is actually in the description, so you don't have to go ahead and search for it. We already have you covered. So thank you.
So thanks so much for having me.